Hello guys, today we are going to look at derived quantities. What are derived quantities? Derived quantities are those quantities that depend on the fundamental quantities. That means it can be obtained by the combination of two or more fundamental quantities, and their units are equally called derived units. Follow me so that I can show you how we can get the derived units of other quantities. See you. The first one we are going to look at is the area. The area is equals to length times breadth. The length is measured in meters and the breadth is measured in meters. Now from the law of indices, if the bases are the same, it's multiplication. We're going to take one of the bases and add the powers. Now these meters have invisible power of 1, so we're going to have meter 1 plus 1, which will give me meter squared. So the unit of area is meter squared. The next on the line is volume. Volume is length times breadth times height. Length is measured in meters, breadth is measured in meters, height is measured in meters. So we have 1, 1, 1. This gives rise to what? Meter 1 plus 1 plus 1, which is meter cube. Now let's go to look at the speed. The speed is equals to distance over time. Now the distance is measured in meters, whereas the time is what? Seconds. From the law of indices, if the base is in this form, we are going to take the denominator up with a negative sign. That means this one have power of 1 is going to come up to be what? Meter per what? Second. So we call it meter per second. Meter per second. The next we are going to look at is velocity. Velocity is equals to displacement over time. Displacement is equally measured in meters, while time is measured in seconds. So I'm going to have meter per second, meter per second. But mind you, speed and velocity, they have the same unit. But the only difference is speed is a scalar quantity, while velocity is a vector quantity. But we do that in our next video. So let's continue. So we have acceleration is equals to velocity change over time. Velocity change, units of velocity is meter per what? Second. We divide it by the time, which is what? Second. By the time we carry this second up, we are going to have meter per second, which will give me what? Meter per second square. Meter per second square. Meter per second square. The next, we are going to have force. What is force? Force is mass times acceleration. Mass times acceleration. And mass is measured in kilogram, while acceleration is measured in meters per second square. By the time you multiply this, you're going to have kilogram meters per second square. Kilogram meters per second square. Although force is equally measured in newtons, is measured in newtons. But we need to know this as a unit of force, so it can help us to get the dimension of force. The next we are going to have is momentum. Momentum, we have mass times velocity. Unit of mass is kilogram, while unit of velocity is meter per second. When you multiply, we have what? Kilogram meter per second. Then the next you are going to have is work. Work is equals to force times distance. Force times distance. Now we already have the unit of force, which is what? Kilogram meter per second square. We are going to put it second square, we multiply by the distance. So we have meters. Now look at it. We have meter here and we have meter here. So this meter has power of 1, power of 1. We're going to use the law of indices to connect both of them by saying this is what? Kilogram meter 1 plus 1 per second square, which gives rise to what? Kilogram meter square per second square. Now the unit of work is kilogram meter square per second square. Although work is equally measured in joules. Is equally measured in what? Joules. Thank you.